Hi there, in this video I'm going to do a past exam question on algebraic division, the remainder and factor theorem. So let's take a look at the question. Question number 5. f of x is x cubed minus 2x squared plus ax plus b, where a and b are constants. When f of x is divided by x minus 2, the remainder is 1. When f of x is divided by x plus 1, the remainder is 28. And in part A, find the value of a and the value of b. Now, this problem concerns the remainder theorem. So what I'm going to do is, let's create an equation to work out the remainder when f of x, the polynomial, is divided by x minus 2. So let me show you the steps of the remainder theorem to help us create such an equation. So back to the paper and pen. Now, here's the remainder theorem steps. Step number 1. To help us find that remainder, we let f of x, and f of x is the polynomial, and that's been given to us in the problem. And we take the linear. So if we go back to the screenshot, so I'm creating an equation using the remainder theorem for when f of x is divided by x minus 2. So x minus 2 is our linear, as the highest power of x is 1. So if we go back to the paper and pen, so we take that linear of x minus 2 and we always equate to 0 when it comes to the first step of the remainder theorem. Now when I rearrange here, the x value is 2. Now that takes us to the last step, step number 2. Now I'm going to call this remainder R1. So therefore the remainder R1, and to work out R1 is f of whatever value of x you have over here as a result of step 1. So we need to work out f of 2. Now to work out f of 2 is straightforward. All we do is we look at our f of x and replace the x's by 2's. So by doing that we'll have x, which is 2, and it's 2 cubed, minus the 2 into x, which is 2, so 2 squared, plus a into x, which is replaced by 2, plus the b at the end. So this is what you have as a result of replacing the x's here by 2's. And let's continue. So let's continue to simplify. 2 cubed is 8, minus 2 times 2 squared is 8 also. A times 2 is 2a, plus the b at the end. And as 8 minus 8 goes, so 8 minus 8 is 0, R1 is 2a plus b. So this is R1, this is the first remainder simplified to the maximum. Now if we go back to the screenshot, it does say that when f of x is divided by x minus 2, the remainder is 1. So if we go back to the paper and pen, we found R1. This is the remainder when f of x is divided by x minus 2 using the remainder theorem, but we have the value of R1. So since R1 is 1, given by the question, if I replace R1 by 1, then I'm going to have one equation which reads 2a plus b, and that is equal to 1. So let's call that equation number 1. Now if we go back to the screenshots, it also says that when f of x is divided by x plus 1, the remainder is 28. So let's go through the remainder theorem again to work out a second remainder R2. So back to the paper and pen. So let's go through these steps. In step number 1, we let f of x is the polynomial, so let's copy this down. So it's x cubed minus 2x squared plus ax plus b. So let's copy down the x cubed minus 2x squared plus ax plus b. And If we go back to the screenshot to remind ourselves, the linear is x plus 1. So back to the paper and pen, so we make x plus 1 and we equate it to 0. So it's always 0 when it comes to step 1 of the remainder theorem method. So if we rearrange then, x is minus 1, that takes us to step number 2. So in step number 2, let's work out the remainder and let's call this remainder R2. So therefore the remainder R2, so R2 is going to be f of the value of x coming from step 1, which is minus 1. So let's work out f of minus 1. So to work out f of minus 1, very straightforward. Look at your f of x and replace the x's by minus 1's, giving us x, which is minus 1, so it's minus 1 cubed, minus the 2, x replaced by minus 1, so minus 1 squared, plus the a, x replaced by minus 1, plus b. So let's simplify this to the maximum. So minus 1 cubed is minus 1. Minus 2 times minus 1 squared is minus 2. A times minus 1 is minus a plus b at the end. And if I simplify further, minus 1 minus 2 is minus 3 minus a plus b. So this is the second remainder R2 simplified to the maximum. Now if you go back to the screenshot, it says when fx is divided by x plus 1, the value of the remainder is 28, meaning that R2 is 28. So if we go back to the paper and pen, we have R2, but since R2 the value is 28, if I replace R2 by 28 then, we're going to have minus 3 minus a plus b, which is 28. And if I move the minus 3 to the right, I'll have a second equation, minus a plus b, and that is 31. Let's call that equation 2. So to summarise, I've got two equations. I've got an equation 1 here, 2a plus b is equal to 1. I have an equation 2 here, minus a plus b, that's equal to 31. And if we go back to the question is, we need to find the value of a and find the value of b. So let's go back to the paper and pen. So let's take these two equations that I have, let's solve simultaneously. So on the reverse. So the first equation is 2a plus b, that's equal to 1. That's equation 1. So remember equation 1, here it is. Equation 2, minus a plus b, that is 31. So let's write down that. So minus a plus b, that is 31. That is our equation 2. Now, depending on whether you want to calculate a or b first, now I'm going to eliminate b. So to eliminate b, I'm going to subtract. So that minus, let's change it to a plus. That plus will reverse to a minus. The plus here reverses to minus. And when I add the terms, plus a minus b is going to cancel. 2a plus a is 3a, and that is equal to 1 minus 31 is minus 30. So I make a then minus 30 divided by 3 minus 10. So that should be the value of a. So to work out the b value, it doesn't matter which equation that you choose. Let me put the a value into, say, equation number 2. So let me put a, which is minus 10, into equation number 2. So here is equation 2. So it's minus a, which is minus 10, plus b, and that is equal to 31. So when we multiply, minus times minus is plus, so plus 10 plus b is 31. So b, if if I move the 10 to the opposite side, 31 minus 10 is 21. So that should be the value of B. So just to summarise, A is minus 10, B 21. So that completes part A of the question. Let's go back to the screenshot. So in part B, we need to show that x minus 3 is a factor of f of x. Now the word factor of means that the remainder is equal to 0. So if the remainder is equal to 0 upon division of f of x by x minus 3, that means that x minus 3 is a factor of f of x. So let's go back to the paper and pen. So let's apply the factor theorem, which is a consequence of the remainder theorem. So here is the factor theorem, step number 1. So we let f of x is the polynomial. So we have x cubed minus 2x squared plus ax plus b, but we know the values of a and b, so let's insert them in to give us x cubed. So x cubed minus 2x squared, so minus 2x squared. Now a is minus 10, so we're going to have a minus 10x, so minus 10x, and b is 21, so I want to replace, it's a plus 21, so plus 21. So f of x is the polynomial, and if we go back to the screenshot, the linear is x minus 3. So back to the paper and pen, so we also let the linear x minus 3 and we equate that to 0. Okay, so it's exactly the same steps as the remainder theorem that we've seen. Now taking a minus 3 to the right will give us an x value of plus 3. So that takes us to the last step, step number 2. And in this case, let's work out f of this value of x3. And remember the words factor of. Factor of basically means that the remainder upon division is 0. So let's see whether f of 3 gives us an answer of 0. So to work out f of 3, let's simply replace the x's by 3's, giving us x, which is 3 cubed, minus 2 into x replaced by 3 squared, minus the 10 into x replaced by 3 plus 21. So 3 cubes, that is 27. Minus 2 into 3 squared is minus 18. Minus 10 into 3 is minus 30, plus the 21 at the end. Now if you calculate this, you are going to get a 0 value. And remember, since f of 3 equals 0, that does imply that x minus 3 is a factor of f of x. So let's just close the question. So since f of 3 is equal to 0, that means that x minus 3, so x minus this value, is a factor of f of x. So that is how part B is solved. Now if you're unaware of the factor or remainder theorems, I have created videos explaining the method along with examples in that video, and I'll provide a link to that video in the description below. However, we've completed the question and that sadly ends this video. So I hope you enjoyed this video. I hope you found this video helpful. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice related questions and I hope to see you again. Thank you.